we have the equation y equals negative 2 sine of 2x minus pi over 3 plus 4, let's say. Okay, so now we want to write down all the important information. So let's say we have, we know that, let's see, that's not what I wanted. Okay, so let's say we know here's A, here's B, here's C, here's D. Alright, now if we have some information that we can write down first, and in particular I want to write down, like, you know, vertical translations. I want to look at period, I want to find the amplitude, I want to find the cycle. Okay, so let's go ahead and write down the information. So let's start with the vertical translation. This is telling us how much it's been moved up or down. Well, the vertical translation is going to correspond to the letter D. Okay, so D is going to tell us the vertical translation. And so in this case, since it's 4, that means the vertical translation is 4, that means we're going to move the graph up 4. Right? The amplitude, well, is the absolute value of A. Well, the absolute value of A here is 2. But we got to keep in mind that this thing has been reflected. So let's just make a quick note of that. After the sign here, we know that the graph is reflected because of this negative coefficient. Right? So because of this negative coefficient, we know the graph has been reflected. Okay, let's move on. All right, next thing I want to look at is the cycle. So I want to know, you know, where is my graph of sine A? Because it's been moved. We can see, if we look at the argument here, 2x minus pi over 3, well, the 2 and the pi over 3, that's going to affect, first of all, it's been shifted to the right, and then it's been compressed a little bit. So let's see, to determine that, what I usually do is I take my argument, which is 2x minus pi over 3. There is another way you can do this, and if we have time at the end of the video, we're going to go ahead and look at that. Alright, so we have 0 less than or equal to 2x minus pi over 3 less than or equal to 2 pi. Now you're wondering why between 0 and 2 pi. Well, that's normally what a cycle of sine looks like, right? So if we think, anytime we ever think of a normal cycle of sine, we think of it going between 0 and 2 pi. And so that's why I placed the argument between 0 and 2 pi, because I want to know what effect 2x minus pi over 3 has on it. So what we do is we solve for x. So here, adding pi over 3, we get pi over 3 is less than or equal to 2x, which is less than or equal to, well, 2 pi. I can think of that as 6 pi over 3. I'm going to add pi over 3 to that, so it's going to be 7 pi over 3. And then I'm going to divide by 2 on all 3 parts, and so we get pi over 6 less than or equal to x less than or equal to 7 pi over 6. Okay, so this is where my cycle lies. All right, the last thing that I want to find here is the period. So the period is 2 pi divided by this number right here, this number here, 2 pi over b. So in this case it's 2, and so it turns out that my period is going to be equal to pi. All right. The quarter period is equal to 1/4 of the full period. So I'm going to take 1/4 and I'm going to multiply that times my period, which is pi, and so I get pi over. Okay, so now we're about ready to graph. So let's suppose now let's draw up our axes here. So let's come down here. I know I've moved the graph up 4, so I got to make sure I leave myself enough space. Okay. All right, so let's start by drawing in the translation. So I know that the vertical translation is 2, so I'm going to move the graph up 2. So we have 1, 2, so here is, oops, I'm sorry, 4 actually, I'm sorry, it's 4. Let me just go back on that. Okay, so let's see, that's 1, 2, 3, and 4, so here's my translation. Now we're going to think of this as being like our new x-axis, so we've actually moved up the axis 4 units. Now the amplitude is 2, so I know that if this is 4, then the graph is going to bounce, it's going the amplitude too. So from this line y equals 4, I need to go up 2 to 6, and then down 2 to 2, right? So my graph's going to bounce between 2 and 6. All right, now I need to label the x-axis. So to label the x-axis, what I usually do is I look at my quarter period, which is this number right here. Oh, something like that. My starting point of my cycle, and my quarter period. Now notice right now that they do not have the same denominator. And let me explain something here. So the idea here, the reason why I'm so interested in the quarter period is because, you know, a typical graph of sine or any trig function has these 5 key points that we can use to get the shape of the graph. Well, the distance between any key point is the quarter period. So if I know that my cycle starts at pi over 6, then all I have to do is keep adding on pi over 4s to find out all those 5 points. But it would be a lot easier if these two things had the same denominator. So what we're going to do really quick is we're going to find the LCD of those things. And so in this case, if the LCD of pi over, of 4 and 6, or pi over 6 or pi over 4, the LCD of that is going to be 12. So I'm going to rewrite pi over 6 as 2 pi over 12. Okay, so I'm going to use that number. And I'm going to rewrite pi over 4 as 3 pi over 12. Okay. Now, this should make graphing a little bit easier. Okay, so now that means that I'm going to start at 2 pi over 12. And every key point after that is going to be 3 pi over 12 units away. So I'm going to add just 3 pi over 12 to that, giving me 5 pi over 12, 8 pi over 12, 11 pi over 12, and 14 pi over 12. Okay. Fairly easy, right? Okay. And if you have an instructor who wants this to be reduced, you can always just reduce at this point. You know, once you have the points labeled, just reduce and erase, reduce and erase, okay? All right, now let's move on. So now I'm going to plot my points. So we got to be very careful. Now, what we're going to be doing is we're going to be comparing it to the normal graph of sine. So in the back of our minds, we have this graph for sine, okay? And I know I have, like I said, I have these 5 points that help me determine the shape of the graph. All right? And all we have to do is be a little bit careful because we know that a reflection has occurred. So we have to make sure that we reflect the graph at the same time. All right, let's start at 2 pi over 12. Well, the first point is 2 pi over 12. I know that the first point should always start on the axis. The axis in this case is 4. We moved it up. So I'm going to start here on 4. At the second point, it should be at the top of the cycle. But now, since it's reflected, now I'm at the bottom of the bottom of the cycle. So in this case, instead of being at positive, it would be a 6. Now it's at positive 2. 8 pi over 12, we're back on the axis. 11 pi over 12, well, we should be at the bottom of the curve, but now we're at the top of the curve. And then at 14 pi over 12, we're back at the axis again. Okay. And so now we just draw our curve through those points, and then we're done. All right, so that's one complete cycle of sine. And if you needed to draw 2 cycles, 3 cycles, that's another thing about this quarter period, is that you just add or subtract on the quarter periods to get as much of the graph as you need. Okay, and that'll take care of this graph.